now describe the state of the fluid inside the cylinder during the working cycle of the four-stroke spark ignition engine. So this state is best described in what we call an indicator diagram. The indicator diagram is a diagram with as y-axis the pressure and as x-axis the volume. Here we don't have the specific volume like in a Clapeyron diagram, but the total volume inside the cylinder. So in such a diagram we can already plot a few values. In terms of volume, we already have two characteristic volume, which is the dead volume, the clearance volume, that's the volume inside the cylinder when the piston is at the top dead center, and we also have the maximum volume inside the cylinder when the piston is down at the bottom dead center, and the difference between these two volumes correspond to the swept volume of the piston. There's also one characteristic pressure, which is the admission pressure, or the pressure we have on the admission line. And here, in order to simplify the problem, we'll consider that this admission pressure corresponds to the atmospheric pressure. So we can also say that we have the same pressure in the exhaust line of the engine. So let's now describe the different transformations that are taking place inside the cylinder during the four strokes. We'll start with the same point than for the description of the cycle. So we consider that the piston is at the top dead center. We are starting the admission stroke and the admission valves are open, the exhaust valves are closed. Because the cylinder is connected to the admission line, the pressure inside the cylinder is the same, so we have the admission pressure, and the volume corresponds to the clearance volume. So that's the initial state inside the cylinder. Then the piston is moving downwards. When it's moving downwards, it's increasing the volume, so it's called volumetric expansion, and this volumetric expansion tends to decrease at the same time the temperature and the pressure. But due to this pressure decrease, it will also cause flow from the admission line to the cylinder that will equilibrate, so the pressure difference will equilibrate with the pressure losses we have, especially at the admission valve. So if we measure it, we can see that the pressure is slightly decreasing during this first phase, and at the end of the stroke, the piston will slow down because we have a sinusoidal movement. And so because the piston is slowing down, then the flow is slowing down, and the pressures are equilibrating again. We get again the same pressure inside the cylinder and inside the admission line at the end of this stroke. So this first stroke corresponds to the admission stroke, and at the end of this stroke, the admission valves are closing, and now the system is behaving with the transformation in closed system from a thermodynamic point of view. Second stroke, the piston is moving up again, so the volume is decreasing from the maximum volume to the clearance volume. We have a volumetric compression of the fluid inside the cylinder, and when we have an adiabatic compression, a volumetric compression tends to increase temperature and pressure. In a real system, so in a real engine, this compression is not adiabatic. It's cooled down by the side walls of the cylinder because the motor body is cooled. But this cooling is not sufficient to avoid the increase in pressure and temperature, so we will have anyway an increase in this case of pressure inside the cylinder during this second stroke. So this is the compression stroke. Once the compression stroke is over, it's when we want to start the combustion, and so we want to have the ignition of the fuel. For this we use the spark plug, which will ignite the combustion at the top dead center, and in reality it's even a little bit before reaching the top dead center. That's why I stopped here the curve just before the top dead center. That's what we call the advance of the ignition. The combustion tends to increase as well the pressure and the temperature due to the heat that is brought by combustion. So we have a sudden increase in pressure, and at the same time the piston continue moving a little bit. Combustion is very fast. It takes usually below 2 milliseconds, but this time is sufficient for the piston to move a little bit, so the piston will go down to top dead center and again a little bit towards the bottom dead center, and so the combustion is over somewhere over there. Then the third stroke is the expansion, so we get more or less the reverse to what we had during the compression, but now it's starting at much higher pressure. So for this reason the pressure is decreasing, but at the end of the expansion, close to the bottom dead center, the pressure is still much higher than at the beginning of the compression, and it's also much higher than the pressure we have in the exhaust line of the system. So that's the third stroke for the expansion. And once the piston reaches the bottom dead center, or in fact a little bit before reaching the bottom dead center, most of the time the exhaust valves are opening, and it is connecting the inside of the cylinder, so at relatively high pressure, to the atmospheric pressure exhaust line, and this is pushing most of the fluid very fast to the exhaust line, and the pressure difference we get equilibrates with the pressure losses across the exhaust valves. So the pressure is decreasing really fast during this stage, but remains slightly higher than the atmospheric pressure. The last stroke is the exhaust stroke, and during this stroke then the piston is moving up from bottom dead center to top dead center. It's creating a slight overpressure inside the cylinder, so this higher pressure is maintained during this whole stroke, and most of the smoke is pushed out to the exhaust line, and then once at the top dead center the exhaust valves are closing and the admission valves are opening, and a new cycle is starting again.